Hi, I'm Shane, and this is how I turned
This $30 sled.
in a Captain America shield. Now, the reason I decided to make this shield is because I've wanted one since I was 10 years old, but I never had the means to make it. Now, this project took around 6 months on and off. I mostly spent nights, 11 o'clock past, working on it, and weekends, so it was a long time coming, but it's finally done. Now, this process is heavily inspired by that of Ramen Noodle Budgets, who also did the Captain America shield, but I decided to take a lot of liberties and change the process as much as I could just to make it my own. And also I tried to make it a lot more screen accurate to that of Captain America Civil War. Now, let's get started. And for the material I'm using on this build, I could have used stainless steel, but it would have been really difficult to work with since you need special tools and it squeaks a lot. But for the build I'm using carbon steel, which is stainless steel minus the chromium and other alloys that go in there. Carbon steel is just mostly iron and then 0.5% carbon. It'll rust, but if you take the proper precautions, it'll be fine. Another thing that's important to note is that carbon steel and stainless steel have two different colors associated to them. Because stainless steel has chromium infused, it's a little shinier, a little brighter of a tone, when carbon steel is a little bit more matte, a little bit muter of a tone. So whenever I come to do the star, and I'm gonna make that out of a separate piece of sheet metal, I'm gonna need to make that also out of carbon steel and coat the entire thing in clear coat. So the sled I used was actually a little bit thin for metal, especially for something that's supposed to be a shield, but it doesn't actually matter because the curvature of the dome gives it a really nice structure and it won't flop around at all. So first, we have to find center on the dome. I tried the screwdriver and pen method, but it was really inconsistent because the string kept sliding up the screwdriver. So instead, I used a tape measure. It's 27 inches across, so you just measure from all sides and get 13.5 in the center. You just mark that, and all we have to do next is drill the pilot hole. So, now that we have our hole, the next step is to take all the paint off. Problem is, this is powder coating, and powder coating is notoriously hard to get off of surfaces. I actually did a little test here with citrus strip, and after leaving it for a day, it did nothing, and after 2 days, it took off a fair amount of it. So I'm gonna go ahead and put on a layer, see if it works. If not, we're gonna have to try something else. Now to cut the general shape of the shield. The radius from the center to just above these holes is 12 7/16. So we're gonna mark that and cut that and then sand down the edges. Oh, and just a note, due to the sled size being slightly smaller than anticipated, I adjusted my schematics to be 96% of the original size. So here's the origin, the radius, or the radii would be 3.84, 6.72, and 9.6 for the 3 lines on the shield. So to cut out the outside edge of the circle, I'm actually using a metal cutting jigsaw blade. If you're ever going to use one of these, make sure you go slow and put it on a very low setting because you don't want to build up any heat or excess heat in that blade. More heat means more likely to break. You know, something I didn't expect about the cleanup process of the edge of the shield was how loud it was going to be.
Shut up and sit down.
So now that the edges are all clean, I'm going to use this scribe that I made from a coat hanger, and I'm going to mark out all the circles on here. Now the main problem with long-term projects using steel is that steel rusts pretty easily once you wipe off that top coating by sanding. So to fight that over time, since the project took so long, I ended up using Rust-Oleum rust inhibitor, and it's not a paint, but it's an oil that goes over the surface and creates an oil barrier to keep the oxygen from reacting with the iron underneath and oxidizing. So the star actually had to have a diameter of around 7.5 inches, and that's really difficult to do by eye and to get a perfect star out of it. So I went into a program called Inkscape, and in this program I was able to find a picture of the star that I wanted, scale it to what I needed diameter to be, and then print it out. And then past there, I just glued the paper, or taped it rather, onto a piece of sheet metal, cut it out with tin snips, and then engraved it with a Dremel engraving tool. Now, if you don't have a Dremel engraving tool, you can always just use a scribe, which I made from a coat hanger and just ground it down to a point. But you can do whatever fits your means the best. Now, to get the curve in the star to match the curvature of the dome, what I actually ended up doing was taking the star and putting it on a roll of tape and banging it down with a mallet. The sheet metal is around 22 gauge, which is really thin, and that allowed me to take the edges that weren't bent by the tape roll and bend them out with my hands until it matched perfectly. Next up is the bracket for the straps. For that bracket, I ended up using 1/8 inch carbon steel stock. The reason I made it so thick was because I wanted to have more weight to it. And the reason I want to have more weight to it especially was because when it's sitting on your arm, you want that weight to be more towards your arm and less hanging off, and that gives it less of a chance of the shield separating from the bracket over time in use. Now this is my first time really welding, so you're gonna have to cut some slack on the skill level here. What I'm doing is grinding the pieces so that they would fit together in the arrangement that I wanted them to fit, and then I would go in and weld them flat, and then take them to my vise and actually bend them that way and hammer them out. I have the brackets done for the back of the shield. The star is done. All the lines are scored. Probably gonna do a little bit more work with Scotch-Brite on the shield itself to get rid of some of the imperfections, like these darker spots over here. But all we gotta do is weld on the braces for the leather, and then rivet on the leather, and then just final assembly and paint. Don't forget paint. Now, just to note that the hammering is apparently extremely loud, because my cats who live in the basement decide to go and pee on my bed out of spite, and they never do that. And also, if you ever buy a new tool, you need to expect to feel stupid. When I first started welding, I didn't realize my machine was on the wrong setting because I mistook the 1/8 inch stock for 18 gauge, and 18 gauge is much thinner. So it wasn't welding. I got really frustrated and it took me around 2 days to figure that out. And I'm not proud of that, but that's the learning curve. So the bare bones of the bracket's done. Next up is making the loops for the leather to sit in. And I could have done this with coat hangers, I could have done this any other way, but I actually had some leftover stock. So what I did was I took it to my work and I ended up cutting it into thin strips and then grinding out the center of them to make room for the leather to go through. And I used calipers to set the distance of the leather and make sure those holes were big enough to fit through. Now the loops for the bracket took literally forever. I was sitting there with a grinder going away at it and then filing. There's probably a much better way to do it, but I just couldn't think of anything at the moment, so that's I got the job done. And next up I got this 3M automotive tape. It's thin, so it allows you to go around curves really easily. So what I was doing was stretching it out a little bit, setting it down, stretch it out, set it down, and then in the spaces I didn't want to be painted, I would cover them with painter's tape and newspaper. So when I first spray painted the shield, I used some really old cans of spray paint I had lying around, and it looked like I took a shot of red paint, swished it around my mouth, and spit it all over the shield. So I stripped it all off and I redid it. Now the paint I used in the shield was this Duplicolor metal cast anodized paint. It's not cheap, but it's the best one you can use just because it's a very translucent effect, and anodized means that it's sticking directly to the metal. So it's definitely more resistant over time to peeling or flaking off. So after 3 coats of spray paint with 2 light coats and 1 wet coat, it's time to move on to the 2K clear coat. And as a protective layer, I used what's called 2K clear coat. I threw out the can so I can't show you, but you have a red part on top that you take off, you put in the bottom, and you smack on a table, and that is what breaks apart a canister inside of the can. You shake it up, and you have around 24 or so hours to use up the whole can, and then it goes bad. 2K clear coat is a little bit harder of a coat than say a 1K, which would be, or any sort of Rust-Oleum. And this gets harder and lasts a lot longer and keeps its shine a lot longer. And a note, 2K clear coat is especially toxic and poisonous. You can get liver problems, you can get a bunch of other problems from breathing this stuff in. Do not do what I did. Mine was risky, but I sort of knew what I was doing. I had my basement ventilated and I had plastic all up. I locked my cats out of the basement, and still it was dangerous, and I wore a ventilator. But still, always do it in an outside open area where you can extract fumes very easily, and do not breathe it in. See, my lungs have a lot of air and moisture in them, but at least now they're not gonna rust. Now, when it comes to bonding metal without welding, you have a lot of options. You can use any other adhesive out there, but these are the two that I personally prefer. I use JB Weld metal epoxy. It's called steel reinforced epoxy. It works really well at holding things together over a long time. I haven't had any problems with it, but it's more liquidy. So the other option that I choose for, say, automotive projects is actually the, I believe it's JB Weld steel putty. And it's sort of like a putty that you rub between your fingers, and then over time it hardens, becomes sandable, drillable. To put the bracket onto the back of the shield, I tried both, but what I found worked the best was, because I couldn't get the angle of the bracket perfect to the dome, I used the putty to fill in that extra space, and then after it fell off, after a little while of picking it up, then I decided to put the epoxy over the putty. And what that did was it allowed it to get a tighter fit, and it's been really solid so far. Oh, and the star was also put on with the epoxy, not the putty. Now, for the leather straps in the back, I could have used belts like a lot of other people use, but that just didn't sit right with me. I want to make it a little more authentic. So on Amazon, I found these $10, I think they're like 3 foot long pieces of fake leather. They're a dark brown, and they do scratch easy, but that actually helps because Captain America's shield is from World War II, and I'm assuming that it's had some wear over the years. So anything that's not supposed to be vibranium on the shield, I'm perfectly fine with having scratches, scuffs, wear, discoloration, anything like that, because it helps bring out the authenticity a little bit. And then to hold it all together, I use these nickel-plated leather rivets and a setting punch and block that I got off of Amazon for probably like $9 or something. It's really not that expensive, and it really adds to the aesthetic of the entire shield. Now, it shouldn't be surprised that I got all the way to this step and then had no idea how I was going to tighten it. So I ended up designing a bracket out of old coat hanger, which is actually pretty thick, and I made it out of one piece each for each side. And that way it's more of a belt loop sort of thing where it goes, I'll show it. It goes over, back in, and then you can tighten it while it's off of your arm, but when it's on your arm, it ain't going anywhere. So it ended up working out really well. So now you don't want the shield to be able to rotate around your arm, so the way to fix that was I found this outdoor handle. It's nickel plated, and I found it at Home Depot for just a few dollars. What it allows me to do is put the shield on and be able to grab onto something. So the way that the handle was made, it was hollow, so I had to take it to the vise, use a Dremel, grind it out, flip out the outer sides to have more surface contact on the metal so that the epoxy can actually set properly. And all I did after that was bend it to shape and slap it on there. Oh, and it's important that it's nickel plated because nickel plating keeps things from rusting. Nickel doesn't rust, it tarnishes over time. So it'll only get a more cloudy effect, but hopefully over time that'll even make the worn look of the non-vibranium parts even better. And just a quick side note on the difference between rust and tarnishing. Rust is iron oxide, which is formed when oxygen from the air meets the iron from the steel, because it's only a little bit carbon, and that forms a layer of rust on top, and that's that sort of almost like a reddish color. When tarnishing happens to mostly like nickel, it can even happen to it happens to silver, but silver is black. Nickel starts to tarnish, mostly because it releases hydrogen sulfide and sulfur dioxide into the air after the moisture and oxygen get to it. So it's just a different form of rusting, but it's a lot less invasive and it takes a lot longer to happen. Now, I could have left the shield looking like it was, but it had an orange peel effect on it, which it's exactly what it sounds like. It looked like an orange peel, and that's because when the clear coat was drying, it sort of dries in these little ridges. And the way that you get rid of orange peel in any paint job from a clear coat is by wet sanding with a high grit. I went to around 1500 to 2000. You can even go higher, but you can even go a little bit lower if you want. You just want to make sure you get it smooth, and so that and you are using dish soap and water with it, especially to keep it lubricated. And once it's smooth, then you can go in with your buffing compound. Now for the buffing compound, I use this Meguiar's Ultimate Compound. It's a cutting compound, which means it's a little bit more abrasive than other ones, and it really allows you to smooth out the top of the surface while still filling in those imperfections. And that's the purpose of buffing, is to fill in any little divot or imperfection in the surface. I actually made a big oopsie when I was doing it, and I didn't look at my sandpaper before I started going back in after I washed it off. I had a little bit of debris on it and ended up making a circular scratch in the shield, but that's something I'm probably just gonna buff out later. I love the way this project turned out. It's everything I wanted. And I don't do cosplay or conventions or anything, so this is really just for 10-year-old me to be happy over and excited about. Now I know I enjoyed building this, but I really hope you enjoyed learning about it. So feel free to drop a comment or a like and let me know what you think. Let me know if there's anything you specifically want to see me build. I'm always looking for ideas. Thanks for watching and see you next time.